We have more rules than ever before. We have inspectors for our buildings, we have auditors for our finances, we have checklists for our hospitals, we have regulators for our airlines. All this oversight exists for one reason: it is there to protect us. It is designed to prevent catastrophic failures. First we examine the visible problem, then the hidden mechanism behind it, and finally the system effect almost nobody sees coming. Yet these failures continue to happen. This presents a deep and puzzling contradiction. Safety systems are everywhere, but safety is not guaranteed. The systems we build to stop failure often fail themselves, sometimes in plain sight. This is not because the people involved are careless. It is not always because the rules are wrong. The inspectors are often diligent. The auditors are often thorough. The doctors are often highly skilled. The pilots are often highly skilled. They follow the procedures set out for them. They check the boxes. They file the reports. The system appears to be working as intended, day after day. Then, suddenly, it does not. The surprise is not that things break. The surprise is that they break when all the visible signs suggest they should be safe. The reason for this lies deeper than the individual parts we can see and touch. It lives in the invisible connections between them. To understand why oversight fails, we must look beyond the simple story of a broken part or a bad actor. That story is comfortable. It gives us a clear target for blame. It suggests a simple fix: replace the part. It suggests a simple fix: punish the person. But this approach rarely prevents the next failure. The next failure often looks different but stems from the same underlying cause. We must shift our focus from the components of a system to the system itself. We must examine the way things are connected. We must study the flows of information. We must study the pressures that shape human behavior. They are webs of people. They are webs of equipment. They are webs of processes. These webs have their own rhythms, their own pressures, their own hidden rules. When our simple oversight tools meet this complex reality, they can miss the most important dangers. They can create a false sense of security, leaving us vulnerable to the very disasters they were meant to prevent. When a complex system fails, our first instinct is to find the one thing that broke. We look for the immediate visible cause. In an airplane crash, we search for the black box to find the mechanical fault, the pilot error. In a financial crisis, we point to the one bank that collapsed first. In a medical accident, we identify the specific mistake a doctor, the nurse made. This is the surface view of failure. Our minds are wired to see cause and effect in a simple, linear chain. A leads to B, and B leads to C. The official inquiry often has a narrow mandate: find the proximate cause, assign responsibility, recommend a specific fix. When a part fails, we redesign it. When a person errs, we retrain them. These are logical steps, but they're rarely sufficient. This focus on parts is comforting, but it mistakes a symptom for the underlying disease. The broken part is often just the final link in a longer chain. The real causes are hidden in the system's structure, the communication pathways, workflow pressures, and competing goals. To truly understand why oversight fails, we must look beneath the surface at the hidden dynamics of the system itself. These are not parts you can hold in your hand, they are patterns of behavior. For example, a hospital's incentive to discharge patients quickly can clash with safety. A small delay in reporting airline maintenance can let a risk grow unseen. A financial system can look stable right until it collapses. These examples make the invisible mechanisms visible, providing a new lens for seeing the world. Instead of just asking what broke, or who is to blame, you will ask, what were the incentives? Where were the delays? What feedback loops were at play? The problem is not the parts, it is the pattern. People respond to incentives. This is a fundamental truth. Incentives are the rewards. Incentives are the punishments. Some are obvious: sales bonus, a fine, but many are subtle and unspoken. Oversight that ignores incentives is doomed. Rules on paper, quietly bypassed in practice. The official system says one thing, the incentive system pushes another. When they conflict, incentives win. They shape what people pay attention to. They shape where people cut corners. Consider a hospital ward. A detailed 20-step checklist before a procedure. This is the oversight. But the hospital also has a powerful incentive to increase throughput. It needs to treat more patients to stay financially healthy. This creates an unspoken incentive for speed. A nurse or doctor might feel pressure to complete the checklist quickly. They may perform the steps without careful attention. They are not being negligent. They are responding rationally to two conflicting demands. Be thorough, but also be fast. The oversight only checks if the box was ticked, not how it was ticked. In finance, a bank might have strict rules against risky lending. This is the formal oversight. But it might also offer huge bonuses to loan officers who meet aggressive sales targets. This creates a powerful incentive to approve as many loans as possible, even if it means bending the rules or overlooking warning signs. The loan officer's financial success is tied to taking risks that the bank's official policy forbids. The oversight system, with audits months later, cannot compete with the immediate pull of the bonus. The rule is just a suggestion. The incentive is a command. Therefore, effective oversight must begin by mapping the incentives. It must ask, what behavior does this system actually reward, not just on paper, but in reality? Oversight often fails because it is blind to time. It sees the world in reassuring snapshots, but misses the slow, gradual erosion of safety that happens in between. The delay between an action and its consequence hides the growing danger. Imagine an aircraft maintenance team. They delay replacing a part by 100 hours. Nothing happens, so next time they delay by 200. The delayed feedback creates a false sense of safety while the system drifts toward a state of danger. This drift continues until the system hits a threshold, a tipping point. A system can absorb stress, bending but not breaking, until one final small event pushes it over the edge. Think of a plank that sags under increasing weight, then snaps with the addition of one last pebble. The pebble didn't break the plank, the total accumulated weight did. Oversight that only checks for small problems will always miss these threshold effects. We must also understand feedback loops, where a result influences the next action. Some loops stabilize systems, but others are amplifying. For example, if a regulator imposes heavy fines for safety incidents, staff may stop reporting small problems to avoid punishment. The regulator sees declining reports and concludes the system is safer, reducing scrutiny. The oversight has created a dangerous loop. Punishing honesty leads to less information, a false sense of security, and even less oversight. These hidden mechanisms cause real failures in our most important systems. Let's look at 3 examples. In medicine, checklists improve safety, but the system also rewards speed. A surgical team under pressure may rush through the checklist, ticking boxes without real engagement. An audit sees compliance, but misses the erosion of focus caused by this hidden incentive. In aviation, a minor sensor failure, a fatigued crew, and an unusual instruction are manageable alone, but together they can cascade, pushing the crew's cognitive load past a critical threshold. Oversight saw the parts were fine, but missed how they could interact under pressure. In the 2008 financial crisis, individual banks looked safe. But regulators were blind to the system's structure. Banks were tightly connected, holding the same risky assets. When those assets fell, losses spread like a virus, creating an amplifying feedback loop of panic. In each case, oversight focused on the components, but the failure emerged from the system's dynamics, from incentives, thresholds, or feedback loops. The hidden reason oversight fails is that it is designed to see objects, not patterns. It counts the trees and misses the shape of the forest. The solution, then, is not simply more rules or more inspections. It is a smarter, system-aware approach to oversight. This means shifting our focus. We must move from auditing static compliance to monitoring dynamic behavior. We must look for the invisible structures, the incentives, the delays, the thresholds, the feedback loops, that truly govern how a system operates. This is a more difficult task, but it is the only way to make our systems genuinely resilient. What does this look like in practice? First, it means mapping the system's flows. Instead of just inspecting a piece of equipment, follow the flow of information, materials, decisions that surround it. Who talks to whom? Where are the handoffs? How long do things wait in a queue? This helps reveal the hidden connections and potential bottlenecks. Second, it means actively hunting for delays. Measure the time it takes for information to travel, and for consequences to be felt. Significant delays are a red flag, as they can hide accumulating risks. Third, it requires a deep and honest analysis of incentives. Ask what behaviors the system truly rewards, not just what the rulebook says. System-aware oversight also means planning for thresholds. Instead of just checking for compliance with minimum standards, it uses stress tests and simulations. It asks what-if questions. What if 2 or 3 small things go wrong at once? How would the system respond? Finally, it involves looking for and understanding feedback loops. When a new rule is introduced, watch how it changes behavior over time. Is it creating unintended consequences? Is it amplifying a risky behavior? This requires long-term observation, not just a one-time audit. This approach acknowledges a simple but profound truth. You cannot make a complex system safe by perfecting its individual parts. Safety is an emergent property of the system as a whole. Therefore, oversight must be designed to see that whole. It must become less like a checklist-wielding inspector and more like a system scientist, observing patterns, understanding dynamics, identifying points of high leverage. The ultimate reason oversight fails is a failure of perspective. It looks for broken components when the real danger lies in the fragile patterns that connect them. By changing our perspective, we can begin to design oversight that actually works. You've been watching System Atlas, exploring how the world's systems really work. Share your comments below. See you in our next episode.